have an understanding of the fundamentals concerning the ABO blood group and the RH blood group. Before we get into the other minor blood groups, I want us to focus our attention a little bit on the HDFN. Yes, you heard that right, HDFN, which basically is hemolytic disease of the fetus and newborn. And we know that when we have incompatibilities, we can have this developing, especially when it comes on to pregnancy. And because the RH blood group and the ABO blood groups have been implicated in this phenomena, then we have to do a little bit more deep dive into understanding its complexity so that we can appreciate the direction of the importance of the ABO and the RH blood group system. So, while we're here in this sitting, we will be going over briefly what the HDFN is, and then we'll get into some more details as to its significance and its importance. As the name suggests, hemolytic disease of the fetus and newborn. That's HDFN. This is basically hemolytic destruction of the red blood cells, all right? And when we think about this, we want to think about the fetus and the neonate. And this destruction is occurring due to antibodies produced by the mother. So, just from the name, we have an understanding as to what this system is all about. So, what happens is that the mother can be stimulated to form antibodies which can cause complications for the fetus. So in essence, what is happening is that something causes the mother's body to react to an invader or to react to a non-self, and then the mother mounts up a reaction in the form of antibodies, which are usually naturally occurring, right? And this can be due to the previous pregnancy that she had prior, or it can be due to transfusion if she was in need of blood and blood products and she got transfusion in the past. So these are just some things we need to bear in mind while we are understanding the hemolytic disease of the fetus and the newborn. While we're examining this, I want you to understand that before the advent of the RH immunoglobulin, that's the RH IgG, about 95% of cases concerning the HDFN, guess what? They were caused by maternal antibodies directed against the RH antigen, especially the D antigen. So it's the RhD. So now you see why the RH blood group is one of the most important blood group that we need to know. So diseases concerning the anti-D have decreased since the advent of technology, the advent of time that has passed, and the developments that has been taking place. And this decrease had been noted in the 1900s, approximately 1968, when the RH IgG was introduced. So yes, when a mother is in a state where she has the potential to develop antibodies, what is normally given to her is the RH IgG, which is what we sometimes refers to as the Rodak, right? This is to protect her from the fetus and the fetus from her, because we remember that the RH antibody is able, because it's IgG, it's able to cross over the placenta. All right, it can cross the placental line. It can cross, in some instances, the blood-brain barrier. But despite the decrease in the HDFN, RhD continues to remain an important cause of incompatibilities, although the frequencies have been equal or somewhat surpassed by the RBC antibody specificities. All right. So as we continue to investigate, I want you to understand that the initial diagnosis of this kind of situation is usually serological, which means that we're going to be doing these testing in the blood bank department, the immunohematology department. So we're going to be using antigens and antibodies, cause complex cause a reaction, determine if there's a react them together and determine if there's a reaction. If there is a complex formation, then that would be indicated by what we consider to be agglutination. And once agglutination is observed, then we can proceed to determining what is actually causing this. So when we realize that there is an antibody that is present, then we move into the procedure of what we call identification. So this here is a relatively long procedure, but it is doable. And once you understand the principle, it will all make sense to you why a particular procedure is being done. So let us see if we can examine a little further, do a little deep dive to see if we can put in our mind the process of occurrence. After we have done the serological tests, after the detection has been done, the risk stratification and management of the HDFN has been improved because of the advance of technology. In this modern time period, in this era, we have ultrasonography, we have Doppler's assessment of the middle cerebral arterial peak systolic velocity. We have the chordiocentesis. We have the fetal DNA analysis from the amniotic fluid or the maternal plasma, and intravascular intrauterine transfusion has greatly increased the success of accurately diagnosing this kind of condition and also aiding in the treatment. So technological advancement has been a blessing for us. So this here is of clinical significance. Many people tend to overlook it, but once you are dealing with saving lives, you have to understand things which may not be important to some persons, but they are truly important to us, especially in the laboratory setting. When a mother goes in for labor, it is a life and death situation, and before she goes in, there needs to be the pre-assessment. That is why she has to go to her gynecologist, or she has to take some precautionary procedure before she comes in to give the delivery, so that we can assess what is happening. We can monitor her over time to pick up on any changes that may cause some complication in the delivery of the child that is present within her. So a lot of working parts have to be in place and work together in cohesion, so that the parent, the mother, the family can have the best possible outcome. When we think about it, I want you to think about the clinical findings that usually occur in the fetus and the newborn. What are some of the things that may be reported when we have a situation of HDFN? Well, there was a postulation in the 1930s, about 1939, by Levine and Stetson, Stetson, I think it was, Stetson, Stetson. They reported a transfusion reaction from transfusing a husband's blood to a postpartum woman. When this was done, they postulated that the mother had been immunized to the father's antigen through fetal maternal hemorrhage, which they classified as FMH. All right. So there were antigens present, and this is what they are postulating. So, but the antigen that were present were later determined to not have been what they actually thought, but it was antigens of RhD in nature. So the maternal red blood cell alloimmunization can be caused from previous pregnancy or previous transfusion. So everything that happens plays a part in how we adapt to the situation, how we change, our bodies react. So I know a lot of persons like to be topped up with their blood supply when their hemoglobin is low, but that there, though it may be beneficial, if it's not urgent or necessary, it would be more ideal that you just change your diet, stay still, stay in a position which does not cause your body to be compromised too much, and try to build up your hemoglobin naturally. But if that can't be done, then you'll have to go to get a transfusion. What I want you to understand is that each transfusion that an individual gets exposes them to someone else. And remember, even though we may have the same blood group, we may not be 100% match. But in the assessment, it may appear to be a match. So even in those cases, every transfusion is an exposure opportunity. And the less exposures you have, the better it is for you. All right? And pregnancy also is an exposure because of the ability of the IgG to traverse the placenta. In our large international cohorts, we noted that infant mothers paired that had severe HDFN, most maternal alloimmunization were due to previous pregnancy. That accounts for about 83%, right? While about only 4% were due to previous transfusion. And 14 were undetermined. And this undetermined could be based on environmental exposure and other factors. Because you know that if you come in contact with certain illnesses, your body may produce antibodies which may look like something that the body doesn't have, but when somebody else's blood comes in, the body looks at it as something similar and treats it as that. So a lot of things can take place, right? So HDFN is caused by the destruction of the fetal red blood cell by the antibodies produced by the mother. So the mother is carrying this child, but in the same instance, the mother is trying to terminate the child that she so loves and she is carrying. This happens when the body thinks that the child is a invader, or the child does not have the same look as the mother. So it may seem harsh, but the mother that loves a child sometimes her body looks at the child that is being developed as non-self, which truthfully the child is non-self. But because there is not a complete match, there are some inconsistency that there is attacked. So we need to remember that only antibodies of the IgG, immunoglobulin G, which are IgG class, are actively transported across the placenta via the Fc receptor. Other immunoglobulin classes such as the IgA, IgM, they are not, right? So most IgG antibodies are directed against bacterial, fungal, and viral antigen. So the transfer of the IgG from the mother to the fetus is actually beneficial in most cases, right? But you know that you have cases and then you have those cases, those special situations. So let us look at the pathogenesis. And when we talk about pathogenesis, we want to talk about HDFN causes. But let us look at what are the possibilities or the possible things that may be able to cause HDFN. So when we think about this, we can come to the conclusion that HDFN can be caused by ABO incompatibilities. Yes, that's one of the major blood groups. Then we have the RH, and usually D is the one that is implicated, though the other RHs are also implicated. All right. So the RhD has declined, and more commonly now we have the ABO incompatibilities, which are now the major causes of HDFN. Because we have the ROGAM and preparation and precautions are in place to safeguard, then we have a decline. Statistically, mothers and infants are ABO incompatible in 1 in every 5 pregnancies. So the maternal ABO antibodies that are IgG can cross the placenta and attack the ABO antigen of the fetal red blood cell, right? So the ABO antibodies are present in the plasma of all individuals whose red blood cell lacks the corresponding antigen. Because if the antigen and antibodies are there's going to be complex formation, and that is what we see as agglutination. That's when it happens outside the body, but when it's happening inside of the body, that there is termination, right? So we have to just be mindful as to understand the patient's blood group, the mother's blood group, and the child's blood group. So these antibodies that we're talking about, also called the isohemagglutinin, result from environmental stimulus in the early part of life. And yes, the environment does impact our blood group and our blood expression. So we have to be very careful what we expose ourselves to. Let us look at the group O individuals are, guess what? Most likely to form high titered IgG antibodies, or let's say anti-ABO antibodies. So ABO HDFN is a thing. So ABO HDFN is nearly always limited to A or B infants of an O mother with potent anti-A and the anti-B antibodies. So let us try to revisit the ABO blood group system. In circulation, we have antibodies. On the surface of the cell, we have antigens. Now, the ABO system, we're going to pull out the O from that. And then what is it that we're going to have on the surface of the cell? Guess what we have? We have nothing. But in circulation, we have anti-A and anti-B. So if there is an infant that is anti or is A, what they're going to have is anti-B in circulation. And if they are B, they're going to have anti-A in circulation. And when those come and mix with the mother, one either or is missing, and then there is one that is present that can form a complex. And when that complex forms, we get HDFN due to the ABO incompatibility. So epidemiologically, the clinically significant ABO HDFN occur most frequently in group O mothers who have a group A infant in the white population. Alright, so if the population group is white Caucasian, then we're going to expect it's a O mother who has a A. However, in the black population, it's usually a O mother who has a B infant. And it appears to more likely occur when the antibody titer is higher than 512. Alright? So yes, when the antibody is observed, when the antibody is there is precaution that is done to do a titer so that they can know to what degree of reactivity, what degree of sensitization is actually occurring. And once that degree of sensitization is known, then they can take the necessary steps, and then they can see if the therapy that is being administered is actually working to resolve the situation that is present. So ABO HDFN can occur in the first pregnancy and in any, but not necessarily all subsequent pregnancies, because it does not depend on the previous foreign red blood cell stimulation. There is something that is important for us to remember, and that is tetanus toxoid administration and helminths parasites infection during the pregnancy. They have been actually linked to the production of high titer IgG ABO antibody and severe, very severe HDFN. So if you are a woman and you are pregnant, you have to try to avoid getting certain kind of vaccination. That is why they always say, if you're pregnant, don't take this, and try to stay away from parasitic infestation and infections as much as is possible. You have to try to be as sterile and safeguard not only yourself but your fetus that is within you. So when we are examining this big picture, the understanding that I want you to get is that HDFN with the ABO is typically mild. Yes, It's a mild. Even though it can cause death, this one is mild. In relation to poorly development of the ABO antigens on the fetal red blood cells, right? But the ABO antigens are not fully developed until after the first year of life, and because of that, it is not as significant as with the RhD situation, because those are fully developed at birth, so the reaction is going to be greater, more significant, more impacting. All right. So group A infants red blood cells are serologically more similar to the A2 adult cells, with group A2 infants the red blood cell is much weaker. The weakened A antigen on the fetal and neonatal red blood cell is more readily demonstrable with humans than with the monoclonal anti-A reagents. So as expected, group A2 infants are less likely to have ABO HDFN. Alright? So remember, we have A1 and we have A2. We spoke about that when we were talking about the ABO blood group system. So we have that as a mental picture so that we can understand exactly what is taking place. So, like other forms of the HDFN, the severity of the disease is independent of the presence of the positive DAT. So the DAT result may be positive. It may demonstrate anti-A, maybe anti-B, anti-AB in the illusion of the infant's red blood cell. The ABO HDFN causes some things in the chemistry section of the individual's biochemistry. So we need to know this. Bilirubin peaks at about 1 to 3 days, which is later than HDFN that is caused by other antibody specificities. Right? The phototherapy is usually sufficient in reducing or slowing the rise of the bilirubin level. And if you're in a tropical climate and you don't have access to phototherapy equipment, you just carry the baby out in the sun. Yes, you heard me correctly. You can carry the baby out in the sun and it will resolve and put the body back into gear so that it's cut down the bilirubin and the baby will have a natural and normal life. But the phototherapy system is usually a controlled system. Sun exposure is important in adults and in also infants. All right. So remember that. Rarely, when there are rapidly increasing bilirubin level, IVIGG or exchange transfusion group O red blood cell may be required. All right. The serious consequence that we have observed in relation to this HDFN is usually death, or what we call stillbirth. So you just have to be very careful and very mindful of the possible consequences that exist. Let us do a little comparison so that you have some idea as to the differences between the ABO and the HDFN. So, first pregnancy affected by the ABO, yes. When coming out the RH, that is usually rare. Disease prediction by titer for the ABO, not really. That's a no. The RhD, we can say yes. For the ABO, the causative antigen, IgG, yes, which is usually anti-A and anti-B. And for the RH, we are thinking about the anti-D as the main one. There are others, but that is the main one. When there is ABO, HDFN, when we think about the bilirubin level, that is usually within the normal range. However, when it is for the RhD, it's usually elevated. We can have some intervention with an intrauterine transfusion. For the ABO, it's not really necessary. It's not necessary, so we don't need to do that. But for the RH, sometimes it may become necessary. When the infant is born, there is usually no anemia at birth for the ABO HDFN. But for the RhD HDFN, there is usually anemia present. Phototherapy is beneficial in both cases, so just remember that. Exchange transfusion is rare for ABO HDFN, and it's uncommon for the RhD HDFN. So that is just some of the things that I want you to be aware of. This is just the tip of the iceberg. We will have to get into a little more detail so that you can have the grand understanding as to the hemolytic disease of the fetus and newborn. So in our next sitting, we will continue on this journey, but for now, digest the information and see you in the next sitting.